Good morning, good afternoon again, Matrix. So we had segment number 4. Hope you're excited, and we're still looking at analytical geometry. This is the last video of this 4-part series, and in this last video we're gonna wrap up the last thing you need to know about circles. Obviously there's other things that you need to go through, and you're going to see how those things pop up in past papers and stuff like that. But this last thing that we're going to be looking at is the relationship between two circles. And when I say the relationship between two circles, I need to really break it down for you. So we could be given two circles, right? The green and the red. And if you notice, the red is much bigger than the green, right? And so if I speak about the relationship between these two circles, I could start by mentioning the fact that they touch at 2 points. So I could say touch at 2 points, right? And what else can I say about these two circles? Is that when they do touch, they're touching externally in the sense that they're not actually inside each other. The green is its ratio of how much is inside the red and how much is outside of it. The one outside is more, and that means that these guys are touching externally. They're touching, but they're touching with the green one being outside of the red one. Do you get what I mean? And so that is the relationship between these two circles. Now if I give you another set of circles, give you the red, and I give you the green. You see now that whatever I was describing in my previous example this one looks totally different from that. Do you notice that? And the characteristic of this guy is that, yes, they still touch at 2 points. So they touch at 2 points. But now, they're not touching internally. They're not touching externally. Now they're touching internally. The green is internal to the red. So they're touching and the green is internal. So these are the characteristics when I speak about the relationship. These are the stuff that we're going to be bringing up. These are the stuff that we're going to be speaking about. So just remember that, because this is what we're going to be using to speak about this. Alright. So there's a couple of things that we need to do, right? First of all, let me draw you a spectrum of how these circles could have a relationship between each other, right? On the far end here, and that point, I'll call it an R plus an R, right? And what does that R plus an R mean? I'll speak about it later on. So on the far end of the spectrum, I have these two types of circles. The big one there, and there's a small one right close to it. So I mean, after the point of R plus R, after that point, you get these type of circles, and these two circles, the big R is for the radius of that guy, and the small r is for the radius of that guy. Alright? And on that other end of the spectrum, these two circles are not touching. So they're not touching. And also, they're not touching, and the smaller one is external from the bigger one, right? And so, say it's external. So they're not touching and it's external, right? And on this far end of the spectrum, where R, the big R minus the small r, but if you get values less than that, then the circles look like this, right? Where you still have your big R there, and this one has a small r, right? So the circles look like that, and how do you explain this? This is that they're touching. Oh, well, they're not touching. Sorry. They're still not touching. And the fact that they're internal. The smaller one is internal, the big one. Right? And so at that point, at this critical point where the big R minus the small r, right? As soon as we take the big R and we subtract with the small r, and we calculate the distance between the centers, so this D value, we're going to speak more about it. The D stands for the distance between the centers. That's what that D value stands for. It's the distance between the centers. So what we're actually doing in this exercise is we're calculating what that D value is, right? And then once we're done calculating it, we're going to look at the spectrum and we're going to be like, how does the D value tell us how far these circles are from each other? If the D value is higher than the R plus R, then these circles look like that. They're further from each other, they're not touching, and they're external from each other. So they look like that. If the D value is less than the R minus the small r, the big R minus the small r, if it's less than that, then it means that these circles look like this. That means you have the big circle, and inside that you have a smaller circle, but they're still not touching. And then what happens at this point here? So at the point where R minus R is the same as the D value, if the D value is equal to R minus R, then these circles look like this. So they touch, but they only touch once. So I repeat, once you've calculated your distance between the centers, and that value is the same as when you subtract the bigger radius with the smaller radius, then these circles look like this. They touch. Wait, sorry. My bad. It's the other way around. So these circles, you have the big circle and the smaller one is touching, but it's internal like that. So it looks like that. And this distance here is your R, and the distance going there is your R, your big R. Do you get it? So yes, they're touching, but they're touching at one point and they're internal. So the characteristic of this guy is touch at one point and they're internal. Right? And then what about this guy right here? Let me bring him a little bit closer so that he doesn't look like he's the same as that guy. These guys look like this. That's the first one I drew. They also touch, but they're touching externally. So here is when D is equal to R plus the small letter r. These are the type of circles you get. So they touch also. They touch at one point and the external. Right? And so now we have this range in between. The range in between where D is equal to R minus R, and the range where D is equal to the big R plus the big R. What happens in that range? Then in that range, if you are a very logical person and if you're seeing what's happening there, and if you're seeing what's happening there, then you will conclude that actually what's happening here in the middle is that they touch, and they touch at two places. So that's what happens here. You still have your R there, and this is your big letter R. So here is where D is in between these values. And so what are the characteristics? They touch twice. So the fact that they touch twice, you don't need to speak about whether it's internal or external. They're already touching twice. So the proximity of how much internal or how much external, we're not really gonna talk about that, right? So we're gonna leave it there, and we're gonna actually go into some of the calculation. So this is the frame of mind you need to have, right? And so what are the actual calculative things that we're gonna be finding? We're always going to be finding the D value, and the D is the distance. Distance between centers. So we're always going to be finding that value of D, and what else are we finding? We're always going to be finding what R plus R is, and also what R minus R is. And then we're going to be comparing those values. We're going to draw a number line, and we're going to determine where exactly is the value that we just calculated, the D value, right? So erase all of this. That was just an intro, guys. I know it took a while, but you needed to actually have this frame of mind to actually understand what's going on here, right? So how do these questions get tested? They'll give you two equations. And the question will be, describe the relationship. That's how the question is going to read. And they'll give you equations like x plus 1 squared, y plus minus 3 squared equal to 9. And then they give you another equation. Right? So you have two equations of two circles, and now from that you need to actually get out the information of what are the centers, and what are my radiuses as well. So first of all, the center of this one, I'll call it center of 1. The coordinates of that is -1 and +3. And what is the radius of 1? The radius of 1, if that's an r squared value, then the radius will be a square root of that, right? So r is actually square root of 9, which is 3. Got it? And we're going to go this side. We're going to call this center of 2. And there we have a -3 and a +2. And the r, I'm particularly using the big letter R there, and particularly using the small letter r, because this radius is smaller than that other radius. So here we have a square root of 36, which is a whole 6 units. This one is 3 units instead, right? So you're still with me, right? So from this, we need to calculate D. And D, like I said, it's the distance between those Was this minus? Yeah, this was minus. X1 minus x2 squared, y1 or y2 minus y1 squared. That's the distance formula, guys. So x of 2 is this one here, negative 3 minus, I'm adding a 1, y of 2 is 2 minus 3 squared. So what is the distance of that guy? The distance of that gives me, just checking here, it's the root of 5. That's what I got for the distance. And if you check properly, the root of 5 is 2.24. Right? So we're going to use that value. What else do I need to calculate? I need to calculate what r plus r is. R plus r is that 6 plus that 3, which I get 9. Right? I need to also calculate what r minus r is. The big R minus the small letter r. So it's a 6 minus the 3, I get a 3. So if I were to draw my number line, I'd have a 9 up there. I'd have a 3 down there. Right? So this is my r minus r, and this is my r plus r. Right? So where is my value? My value is right there, the 2.24. So a value that is right there, if you remember my spectrum, the first spectrum that I drew, I said at that point where r minus r, at that point is where they touch each other, but they only touch once. So if I get lesser than that point, that means these guys move further and further away from each other. But they internal each other. So what do I say here? They look like that, these guys. So how do I interpret that in words? They're internal and they don't touch. Not touching or don't touch. Not touching. Right? So that's how the picture will look. And basically that's what they wanted from us. Let me do one more with you guys. Give me a second. Oh, there's another one here. Number 2, x plus a 2 squared plus y squared equal to 4. X minus 3 squared plus y plus 3 squared equals to 9. So again, step 1, what do? You get out your center coordinates out of there. So here I know it's going to be a negative 2. The fact that there's nothing there means it's going to be a 0. Center coordinates for that guy, that's going to be a positive 3 and a negative 3. My radius for this guy, small letter, because it's a 4 and a square root of 4 is just 2 units. Big letter because it's going to be a square root of 9, and the square root of 9 is just 3 units. Right? What else do I need to calculate? I need to calculate d. And what is d? It's just the distance between these two guys, C1 and C2. So I write my formula first. x2 is that one there, the 3, plus the 2 squared, and negative 3 minus the 0 squared gives me, what does this give me? That's a 5 squared, which is a 25, and that's just a 9. So it's a 25 plus 9, which is root of 34. So that is what D is, right? The root of 34 is somewhere between, I don't know, the root of 36 is 6, and the root of 25 is, so it's somewhere between, it's 5 point something, 5.5 or even above it. It's 5 something. I don't have my calculator here, so I can't actually find that value, but it's going to be above 5 but below 6, right? Now let me find my R plus R value. R plus R value, it's this 2 plus that, which gives me a 5, right? R minus R value, it's a 3 minus that 2 gives me a 1. So if I draw my number line, I have a 5 there where my R plus R is. R minus R is a 1 there. And so I know for a fact that it's not between that range. This guy is going to be somewhere there. 5 point something will be somewhere there. And because he's outside that range, then the circles look like this. They're external from each other and they're far away from each other. So what does that mean? It means not touching and they're external. So that's the reasons you're going to get for that. They're not touching and they're external. So yeah, that's it for circles. That's it for the relationship between two circles. You can do those and you can interpret it a lot of ways. Like take this example, for example. Let's say that guy was 5, was the square root of 25, and so he gave us 5 exactly. What would that mean? It would mean that my new point would be there now, as red. And it will be 5 there. And so what does that mean? It means that my circles touch, but they touch externally like that. So they touch at one point. Sorry, I'm trying to depict touching at one point. So they touch at one point and they touch externally like that. I hope you can see that. And let's say the value here was square root of 16. Square root of 16, you get a 4 there, right? And the square root of 4 will be, square root of 16 will be 4, and 4 will be there. And so what does 4, the range in between, what does that mean? It means my circles, they do touch and they touch twice. So all I needed to say is that they touch and they touch twice. So do you see how you interpret this given any value that you got for D and given the range that you're looking at? So that's how you do circles. And this is the end of the 4 series on circles, on analytical geometry. For you to actually see where these get into, how these get tested, you need to go through past papers and a lot of those past papers. And at some point you're going to notice they're always asking for the equation of the circle. They always ask for the equation of the tangent. If I'm given the equation of the circle, they're probably going to always ask for the center and the coordinates of the center and the coordinates of the radius. If I'm given 2 equations of circles, they're always going to ask what is the relationship between those 2 circles. And this is how they're going to ask it. So that's it for me. Hope you got something out of this. Thank you so much, Matrix.